Alright, let's make this simple. Today we are talking about if, else if, and else. At first, these words can look strange. They look like coding words, and yes, they are. But the idea behind them is easy, because computers make decisions not like human. They do not guess, they do not feel, they do not think deeply. They just check something. Is it true or is it false? That's the big idea. Programming uses simple decisions, and from those decisions we can build apps, games, websites, and softwares. So by the end of this lesson, if, else if, and else will feel much easier. So what is an if statement? An if statement checks a condition. That means it checks a rule. For example, is it true or is it false? If the condition is true, the computer runs some code. If the condition is false, the computer skips it. That's it. So the main idea is this. If something is true, do something. For example, if it is raining, take an umbrella. The condition is it raining? If yes, take an umbrella. If no, do nothing. So remember, if means check first. Now let's make it visual. A condition usually has two possible answers, true or false. This is a bit like binary. Binary uses two states, 0 and 1. Here code also uses two states, true and false. Let's ask a few questions. Is it raining? Is the score above 90? Is the user logged in? Is the person 18 or older? Each question has an answer. Yes or no? True or false? If the answer is true, the computer runs the block of code. If the answer is false, the computer skips the block of code. Simple. The computer is not guessing. It is just checking. Here is the important part. You already understand if statements because you use them every day. Think about it. If it rains, you take an umbrella. If you're hungry, you eat. If you are tired, you sleep. That's the if logic, and you already do it naturally. Programming just writes this logic clearly, so a computer can follow it. That's why coding is not magic. It is real-life logic written step by step. So when you see an if statement, don't panic. Just ask, what is the condition? And what happens if it's true? Now we know what if does. But what happens if the condition is false? That's where else comes in. Else is the fallback. It means if the first thing is not true, do this instead. Let's go back to the weather example. If it rains, take an umbrella. Else, wear sunglasses. So now we cover both cases. Rain, umbrella. No rain, sunglasses. The if handles the true case. The else handles the other case. So remember, else means otherwise. Now let's add one more idea. Sometimes life has more than two options. It is not always just yes or no. For example, if it rains, take an umbrella. But if it is not raining and it is cold, then maybe you need a jacket. So we can say, if it rains, take an umbrella. If else is it cold, wear a jacket. Else, wear sunglasses. That's what else if does. It checks another condition, but only if the first condition was false. So else if means, okay, the first condition was false. Let's check another rule. This creates a chain of decisions. Now let's look at the flow. The computer checks from top to bottom. First, it checks the if. If that is true, it runs that block of code. Then it stops. But if the if is false, it moves to the else if. Then it checks that condition. If that is true, it runs that block of code. Then it stops. And if nothing is true, it goes to the else. The important rule is this. Only one block runs. Not all of them. Just one. The first one that matches. So the order matters. The computer follows the path, step by step, top to bottom. This is one of the most important ideas. The computer does not run every branch. It chooses one path, only one. The if is checked first. The else if is checked after, but only if the if was false. The else run last. It only runs if nothing else matched. Think of it like a door. The computer walks down the hallway. It checks the first door. Can I enter? If yes, it enters and stops. If no, it tries the next door, then the next. So again, only one path is chosen. That's the key rule. Now that the logic makes sense, let's look at the code. Here we have a score, and we want to give a grade. The code says, if the score is greater than 90, the grade is A. Else if the score is greater than 70, the grade is B. Else, the grade is C. So the computer checks each line, one by one. It does not guess the grade. It follows the conditions. This is why I explained with real life first, because the code is just the same logic, written in a programming language. Now let's break it down. Imagine the score is 85. The computer starts at the top. First question, is 85 greater than 90? No, that's false. So the computer moves down. Second question, is 85 greater than 70? Yes, that's true. So the computer chooses that block of code. The grade becomes B, and then it stops. It does not check the else because it already found a true condition. So remember, the computer checks top to bottom and it stops at the first true condition. So why does this matter? Because apps and games use this everywhere. When you enter a password, the app checks it. If the password is correct, you are logged in. If not, you see an error. In a game, if your health reaches 0, game over. On a website, if you click a button, a page opens. In an online shop, if your cart is empty, you see a message. These are all conditions. Small decisions checked by the computer again and again. That's why if statements are so important. They are one of the foundations of programming. Let's recap. An if is a decision. It checks a condition. If the condition is true, the code runs. An else if is another check. It gives the computer another option. An else is the fallback. It runs when nothing else was true. The computer checks from top to bottom. It follows the first true path, and only one block of code runs. So if statements are not scary. They are just simple decisions, repeated many times. That is programming. Simple rules, clear steps, logical thinking. So here is the final idea. A computer does not understand things the way humans do. It doesn't know what is best. It does not guess. But with clear conditions, it can make decisions. And those decisions can power huge systems, apps, games, website, the entire digital worlds. That's the magic of coding, not real magic, just logic, tiny rules, combined together to create big results. So remember, if, else, small logic, big power.